In this chapter, we will be studying topics in trigonometry. This lesson will be a brief introduction to the sine law.
All right, hi everybody. So here we're going to take a look at the sine law, because what we see here is not every triangle that we're working with is a right angle triangle. In fact, sometimes we're looking at what we call oblique triangles, okay? And these are triangles, you can guess here, that do not contain a right angle. Now, before we get into this, for what we're doing here, please make sure you're in degree mode. Oh, it's so frustrating when you're doing the right thing on the calculator, but you're getting the wrong answer because you're in the wrong mode. Now, before we get into actually using this thing called the sine law, I just want to show you really quickly where it comes from here. So take a look at this triangle right here, and I better zoom in on this just so you can see it here. So it's labeled A, B, C, and then we've got little c, little a, little b here, and we're going to drop an altitude right here, because even when we're working on the, oh, it's not coming in super clear here. Anyway, so there's B here. I'll draw this out like this here. A, does that make it any better here? Oh, not a lot. Okay, anyway, A, C, B, and then this is little h here. So even when we're looking at like an oblique triangle here, if we're going to use regular trigonometry to kind of help us, or sorry, I should say it like this, we typically use regular trigonometry to help us create other patterns here. So we're going to drop this altitude, and then we've got two right angle triangles here. So in this triangle right here, notice that the sine of A is going to equal h over c. Here's A, h over c. Okay? And then I can multiply basically up by the c to get that h is equal to c times the sine of A. I can do the exact same thing with this other triangle. Okay, there's my angle C. The sine of C is going to be h over A. H over A, and then I can multiply up by A to get h is equal to the A times the sine of C. Now, because these two expressions here are both equal to h, I can set them equal to each other. If you want to give that a name, it's called the transitive property. Okay, this is equal to h, this is equal to h, so these two must be equal to each other. And then I can do one of two things here. I can either divide both sides by c and both sides by a to get this expression, or I can divide both sides by the sine of a and the sine of c to get this expression. But either way, what we get here is a relationship where the length of the side divided by the sine of the angle opposite it should be equal to the length of another side of the triangle divided by the sine of the angle opposite it. Okay, and that's the sine rule, or the sine law. So in general, this is going to be true, okay, with any triangle here, that the ratio of the side length over the sine of the angle opposite should be true regardless of what angle side pair you take. Now, this is an incredibly useful tool because all I'm doing is setting up proportions, and then you're going to see me, I'm just going to multiply across and then divide to get the thing that we don't know. Okay, so here's the sine law. Now let's take a look at a couple of examples of this. Okay, so here for our first question, we read here, find the value of x to the nearest tenth. Okay, I got to bring the triangle over here. You can't see it. Okay, and so it's not 100% clear here. Here we go. So here's 60 degrees, and the length of the side opposite that is 7. And here I've got 80 degrees, and I'm looking for the length of the side opposite that. So if we give these things names here, it doesn't really matter what we call it here, A, B, C, then we're looking for side little a, and we've got side little b here. So the ratio that I can set up, if I go the other way here, I can set up little b over the sine of angle b is equal to little a over the sine of angle a. And when I go over here, that is going to be 7 over the sine of 60. And one of the things I've noticed, one of the things that I see people do incorrectly here is they tend to forget the sine here. I've watched all sorts of people where they have this kind of vague recollection of how the sine law works, but then they just go 7 over the angle, and they forget the sine, I should say. They do forget the sine. A in this case was my x here, and the angle opposite that was 80 degrees. So it's going to be 7 over the sine of 60 is equal to x over the sine of 80. Now, this is a proportion. So I can cross multiply. Now I know some people don't like that expression, cross multiplying. Basically, I'm going to multiply both sides of the equation by the denominator here, sine 60, sine 80. And that's effectively going to become 7 times the sine of 80 will equal x multiplied by the sine of 60. So, I mean, really, I am just multiplying across the equal sign. Now, to solve for x, I'm going to divide both sides of the equation by the sine of 60. So 7 sine of 80 degrees divided by the sine of 60 degrees. And now I just go to my calculator. But I do want to point something out here. When you enter this into the calculator, it's very easy to do this incorrectly. So 7 sine of 80. Now, it's right here where you could run into a problem. The calculator doesn't close the brackets here. If you just do this, if you go divided by the sine of 60, this is actually incorrect. Because what you're doing here is that sine of 60 is now within the angle here. You're taking the sine of this whole expression. I don't want that. I want to just be taking the sine of 80 here, so I need to insert a bit of parentheses right there. So 7 sine of 80, close, divided by the sine of 60. When I press enter, I'm going to get 7.96. The question was rounded to the nearest tenth, so we're going to round that up, so this will be approximately 8.0. Okay, and there we go. There's the length of that side. Okay, so in this question here it says if triangle XYZ has angle Z equal to 33 degrees and angle Y equal to 112, if Z, little z here, is equal to 28, find sine Y to the nearest tenth. Now the difference between the two questions here is that in this one here, we're not shown the triangle. So now, let's do this. Now I'll make this Z, Y, and X. Okay, I can do that in whatever order I want. I know that Z is supposed to be 33 degrees, and I know that little z, and that'll be the side opposite it way over here, this is going to be 28 units. They don't tell us what it is, and that's okay. And then Y will be 112 degrees, and we're looking for, make this a bit more of an arrow there. We're looking for side Y. So what I need to make the sine law work is I need this pair. I need this angle side pair here, and I've got that. I know that little z over the sine of angle z should be equal to little y, side y right there, over the sine of angle y. Now I know the pieces here. I know this is going to be 28 over the sine of 33 degrees will equal y over the sine of 112. And now I'm going to cross multiply. Okay, and I keep recognizing, I know that some people cringe when I say that. I just want to make sure that I'm acknowledging that. But anyway, that's effectively what's going on here, and you can do that over an equal sign. And then you divide to get the variable here. So it'll be 28 sine of 112 degrees divided by the sine of 33 degrees, and that's going to equal y. So here we go to the calculator. And I just got to make sure I see that. So it'll be 28 sine of 112 divided by the sine of 33. And I make sure that I'm closing off the parentheses after I enter the angles. And I get 47.7 rounded to the nearest tenth. 47.7 is approximately the y coordinate that I'm looking for. Okay, there you go. That's the side. Okay, everybody. Here's a slightly different question. It says find the angle of angle B to the nearest degree. Okay, well the last two questions we were looking for side lengths. Here we're going to look for an angle. So when you look at the triangle here, here's the angle that we're looking for. The side opposite it is 3.6, but we're given this angle of 100 degrees, and the side opposite that is 5.1. So we can label these things here a little bit, but they've already kind of given us this variable here for B here. So let's just stick with that. Let's just jump right to our ratio here. So I know it's going to be 5.1 divided by the sine of the angle opposite it. So 5.1 divided by 100. Or sorry, the sine of 100. See there, I did it right there. I forgot to put the trig function there. Easy to do. 5.1 over the sine of 100 is 3.6 divided by the sine of that angle B. Okay, so now we're going to cross multiply. 5.1 sine of B will equal 3.6 sine of 100. And then we're going to divide. Sine of B will equal 3.6 sine of 100 divided by 5.1. But now, in the last couple questions, that was it. That was all I had to do, because once I pressed enter after that, I got the answer. Here, it's a little different because I'm looking for the angle. So the last thing that I'm actually going to do here, after you've divided here, is we're going to do the inverse sine of that right-hand side of the equation. Okay, so now I'm going to enter that into my calculator. Make sure I see it here. So this will be the second sine of 3.6 multiplied by the sine of 100. I want to make sure that I close the parentheses here, and then do divided by 5.1, close the parentheses there, and press enter. And I'm going to get 44 degrees. B is equal to 44 degrees. Now, that's the angle that we're looking for here in this question. I just want you to be aware of a little thing here. There is a little issue here. There's something called the ambiguous case of the sine law. We're not going to explore that in this particular lesson here. But when you're looking for the angle using the sine law, there are some situations where there's more than one possible answer to the question. Now, for the time being, we're not going to worry about that. I just want you to be aware that there is an issue that will be coming up where you'll take a look at that answer and say, okay, you'll have to look at it at this point and say, okay, is that the only one that works here? Anyway, we're not going to worry about that right now. Just a heads up. Let's take a look at another question. Okay, so this is sort of similar to the pairing of questions that we had before when we were looking for sides. Here, I'm still going to get you to look for an angle, but you're going to have to draw the triangle first. So we're looking at triangle ABC, and so I typically just draw my standard triangle right here. I don't really even care if I've got my angles even roughly close to the right size here. I just want to know the relationships between them. So angle A is supposed to be 43 degrees. Little c here, which is over here, this is going to be 36.1. Little a is 51.4, and I'm looking for angle C. So my ratio here, okay, these two are my pair. I'm going to put 51.4 over the sine of 43 degrees will equal 36.1 over the sine of angle C. That's the thing that I'm looking for. It's a proportion. So once again, I am going to cross multiply. So 51.4 multiplied by the sine of C should equal 36.1 multiplied by the sine of 43 degrees. And then I'm going to divide. So the sine of C will equal 36.1 sine of 43 degrees divided by 51.4. But once again, because I'm looking for the angle, that's not my final step. It's not my final step. My final step here is going to be to take the inverse sine of that. And I encourage you to do this in one step. You'll notice that that's what I've been doing. I've been entering this into my calculator in one step. I encourage you to do that because the calculator, just for example here, when I press like the sine of, let's say, 42 degrees, the calculator gives it to me to a certain number of decimal places, but the calculator is calculating it to even a few more beyond that it's not showing me. There are enough decimal places given here that this should be accurate. This should be accurate for any kind of application that I'm going to apply here. But if you do this in chunks, people frequently round. And when they round, they create a little bit of an error. And after a couple of steps, that little error can get actually bigger and bigger. The calculator here, granted, the decimal should go on forever and for most of these angles here, but it's giving it to me, or it knows the decimal to enough places that if I use that whole decimal, the little error that gets introduced there is so small that even after several calculations, it's not going to affect my result in any appreciable way. So I really encourage you to try to do this in one step as often as you can. So you're using the entire number here that the calculator provides. So that's the inverse sine of 36.1 times the sine of 43, close the bracket, divided by 51.4. I close the bracket for the sine there, press enter, and I'm getting 28.6, but we typically take the angle to the nearest degree, so that's going to be 29 degrees. And there you go. Okay, so now we're going to go back to a type of question that you've done before, but probably with right angles. And now we're going to just take a look at doing the same thing with oblique triangles. We're going to solve the triangles. So here we go. Let's maybe, wrong way. Let's zoom in a little bit. So I'm going to solve this triangle here. Now, just to make my life easier, I'm going to label it ABC. And so this is going to be little a here. So I know angles A and C here. And now I got to figure out angle B. I got to figure out side B and side C. Okay, well, I am excessively lazy. So I'm going to attack or grab the low-hanging fruit here first. I'm going to find angle B, because I know that angle B is going to be 180 degrees minus angle A minus angle C. And when you do that, 180 minus 49 minus 78 is going to be 53 degrees. Okay? Now, once I've got that, it should be relatively easy for me to find all of the sides here. So, for example, let's take a quick look here. I know angle A and side A. I was given angle C. I can find side C. So, here's my sine law. 32.5 over the sine of 49 degrees is going to equal little c over the sine of 78. I'm going to cross multiply, so 32.5 multiplied by the sine of 78 degrees will equal little c times the sine of 49. Then I'll divide by the sine of 49, so 32.5 sine of 78 degrees divided by the sine of 49 degrees will equal c. And then I just do this on my calculator. 32.5 sine of 78. You already know what this is going to look like here. Divided by the sine of 49. And I get to the nearest tenth, 42.1 is equal to side C. Okay. Now, I'm going to find side B. A lot of people are tempted, once they've got two sides here, to use the Pythagorean theorem to find the third side. But please remember, everybody, this is not a right angle triangle. So I can't do that. I've actually got to go back to the sine law. So I'm going to do 32.5 over the sine of 49 degrees. But this time I know angle B. I figured that out. Okay. And so I'm going to cross multiply and divide. Now I'm running out of room here, but I should already have kind of a basic idea of what this is going to look like. B is going to equal 32.5 sine of 53 degrees over the sine of 49 degrees. Okay, so I can enter that into my calculator, 32.5 sine of 53 divided by the sine of 49 degrees. And I get to the nearest tenth there, 34.4. And so there, I've solved the triangle. B is 34.4, C is 42.1, and angle B is 53 degrees. Okay, so here's the next one that I'm going to solve, the next triangle I'm going to solve here. Now notice in this case here, the information I'm given is different. I've only got one angle, but I've got two sides. And more importantly, I know the length of the side opposite the angle that I'm given. So that's an indication to me that I can use the sine law when I've got that pair. Now let's just label everything. So this is going to be little c, this will be a little b. I'm looking for a little a. Okay, so to start off with here, let's do the only thing we can. I can set up this ratio here. I know that I've got 32 over the sine of 105 is going to equal, well, the only other bit of information I have is side C. Well, that's it. Now, the way I've been setting this up, I would put the side on top, but that means I have to put the sine of the angle opposite that underneath. So this is the only thing I can do. I will cross multiply. So 32 sine of c is equal to 25 sine of 105. And so the sine of c will equal 25 sine of 105 degrees divided by 32. And then remember, to solve for the angle, I got to do the inverse sine function of the right-hand side here. I'll go to my calculator. And I've got the inverse sine 25 times the sine of 105, close the bracket there, divide by 32, and then I close the bracket for the sine function right there. Okay, and then to the nearest degree, I'm getting 49 degrees. Now, I can use that right now to get angle A, right? Because I know that angle A, is going to be 180 minus 105 minus 49, right? Because I know that the sum of the angles in a triangle should always add up to 180, so I can always get, just subtract a really simple calculation here. And when you do that, we'll get that angle A is 26 degrees. So now I can go up here and I know that this is 26. Perfect, because now I have the information I need. Okay, I have the angle opposite that side, so now I can set up the sine law to find that bit of information that I'm missing. So it'll be 32 over the sine of 105. Okay, is going to equal A, that unknown, over the sine of 26 degrees. Now, I'm running out of room at the bottom here, so I'm going to do that cross multiplying and dividing just in one step here. So A is going to equal 32 sine of 26 degrees divided by the sine of 105. Okay, now I go to my calculator, and we got 32 sine of 26 divided by the sine of 105. What do I get? 14.5. And you should be noticing here that normally what we're doing is the side lengths typically going to the nearest tenth, angles we're typically going to the nearest degree. And I know what that, I mean, it said that in the question to do that, but that is typically the way we handle these things here. And so here we go, we've solved it. Here's my side length A, here's angle A, and here's angle C. Let's take a look at one more. Okay, so in this question, we're being asked to determine the measure of angle B with the question mark. So we're looking for this angle right here to the nearest tenth. Okay, so in this case, and I just mentioned that we normally find angles to the nearest degree, but in this case they are asking to the nearest tenth. So I'm going to kind of leave stuff in my calculator as much as I can. Now, I've got two triangles here. This is the triangle that I'm really interested in, but I only have 2 bits of information here. I don't have enough, so I need to get at least one more bit of information here. And that is typically going to be that line, that side, that's common to the 2 triangles that I see. So let's call this side right here X. I want to find side X first, and then I'm going to use that to help me find angle B here. Well, in this triangle, where I have the majority information, I have an angle side pair. So I have this 33 over the sine of 110. And I also have the angle opposite the side that I'm looking for. So I can put X here and make this the sine of 36 degrees. Perfect. So now I will cross multiply. So 33 sine of 36 will equal X sine of 110. Then I'll divide. And when I'm looking for the side length, that's really all I got to do. Okay, and so I know that X here will be 33 sine of 36, close the bracket behind the 36, divided by the sine of 110. Press enter, and then I'm getting 20.6 approximately. Whoops, wrote that wrong. 20.6 is equal to X, approximately. Now, I'm going to need this to figure out my angle B, but I'm going to leave that decimal in the calculator for the time being. I'm just going to put the calculator off to the side while I set up my algebra. So now I know this side length and I know that angle. So I know x over the sine of 80 degrees is going to equal 20. I know that the length, 20, over the sine of angle B. There's my question mark there. To get angle B, I would multiply, I'm going to cross multiply, x times the sine of B will equal 20 times the sine of 80. And then I'm going to divide by the thing that I know here. Well, I know x, okay? I figured it out. I haven't written it out, but I figured it out. I know what it is. It's 20.6, and there's more to it than that, but I'm just going to leave it as x here, mostly because I'm just lazy. So this is going to be sine of B is equal to 20 sine of 80 degrees divided by x. I'm even going to go one step further here with that variable to figure out what B is, okay? Every time I look for an angle, I got to finish it with this inverse sine here. So it'll be the inverse sine of 20 sine of 80 over x. Okay. Well, the nice thing is I have x sitting right here. So I'm going to type the inverse sine of 20 sine of 80. Oops, 80. I'm going to close the brackets, and then I'm going to divide by, and to get that number to pop up here. Now, for some of you, all you got to do is move your arrow up to highlight that number and press enter. But for some of you, what you want to do here is press second and then your negative sign to access the ANS, the answer. So what that does is that takes the answer from the previous step and just shoves it right down there. And I'll close the brackets. And when I press enter, boom, there it is. To the nearest tenth, that's going to be 72.6. Angle B is 72.6 degrees. So there you go. I've done a few questions where you use the sine law to find side lengths, and we've done a few questions where you use the sine law to find angles. In terms of the amount of work, it's basically the same. What we're doing is we're cross multiplying and dividing, but when you're looking for an angle, you've got this one last step here. We're going to take the inverse sine. And then lastly, just so that you remember here, there is another little issue here that comes about when you're looking for an angle. Okay, there could be two solutions to your question here. For right now, that's not a concern. We don't want you to worry about it. We just want you to get comfortable using the sine law. But I just want you to be aware that in the future, you might bump into a situation where you look at that and you reevaluate that and say, is there possibly another answer that might also work? Anyway, I hope that helps. I hope that helps this make sense here and that you feel confident moving forward with it.